The truth about an approaching asteroid flyby is far stranger than mainstream headlines are willing to admit. While television anchors reassure the public with neat graphics and simplified explanations, a far more unsettling conversation has been unfolding quietly among independent analysts, astrophysics theorists, and researchers studying patterns hidden deep inside decades of orbital data. Most people watching this event believe humanity fully understands what is approaching Earth. But according to one controversial theory, the object known as JH2 may not be an ordinary asteroid at all. What scientists officially describe as a harmless Apollo-class near-Earth object could instead carry signatures pointing towards something much more mysterious, something that challenges how we think about our entire cosmic neighborhood. Everything began when Mount Lemmon Observatory captured a faint moving object drifting against the stars. At first glance, it looked routine, a dim point of light slowly crossing the night sky. Another asteroid, another catalog entry, another harmless flyby. But within the first moments after detection, something unusual reportedly appeared inside the orbital calculations. According to the theoretical 3IATLAS framework, a speculative tracking model developed by independent researchers studying strange asteroid clustering behavior over the last 2 decades, the trajectory of JH2 did not behave like a typical fragment left behind from an ancient cosmic collision. Instead, its velocity pattern resembled something different entirely, something ejected, something accelerated. That distinction changes everything. Most asteroids entering the inner solar system follow predictable paths shaped by gravity, radiation pressure, and billions of years of orbital evolution. Their movement tells the story of the solar system's violent formation. But JH2 appeared to carry a trajectory suggesting an origin beyond the standard narrative. Some researchers involved in speculative telemetry analysis believe the object may have been launched from a distant source far outside normal detection ranges, not naturally scattered, directed. And that is the part nobody on television wants to discuss. Soon, this office building-sized object will pass Earth well inside the Moon's orbit. News networks have framed the event as a stealth asteroid that suddenly appeared with almost no warning. The phrase sounds dramatic, but according to astronomers, it completely misrepresents what actually happened. JH2 was not hidden behind the sun all day. It did not sneak past weakened defenses. It was discovered exactly when physics said it would be discovered. That matters because the media narrative creates fear for the wrong reason. When tracking systems first identified the asteroid, calculations showed only a short window before closest approach. Headlines immediately turned that into evidence that humanity nearly failed to detect a dangerous object. But the short warning window had nothing to do with incompetence. It was a simple consequence of size and reflected sunlight. A small asteroid only becomes visible once it crosses into a narrow detection envelope close to Earth. Before that point, it simply reflects too little light for ground telescopes to see. No technology currently operating can fully escape that limitation. Within hours of discovery, follow-up observations flooded in from multiple observatories. Officially, scientists claimed they were refining orbital measurements and reducing uncertainty. Yet, according to speculative interpretations of the 3IATLAS framework, researchers may also have been studying unusual characteristics in the asteroid's composition, acceleration profile, and electromagnetic reflection pattern. Then came the designation that almost nobody in the media explained, maximum uncertainty code 9 out of 9. To most viewers, that phrase meant nothing. But within orbital tracking systems, it marked an object whose behavior required extremely careful analysis. And according to independent theorists, the deeper concern was never the flyby distance itself, but whether JH2 fit into a larger pattern already forming beyond humanity's field of vision. Major media outlets transformed the event into a polished narrative built around fear and spectacle. But that explanation collapses under basic celestial mechanics. At the moment of detection, JH2 was positioned far from the sun's glare zone. It was observed at night by a ground-based telescope functioning exactly as intended. Its path across the sky followed a completely understandable outbound trajectory as Earth moved along its orbit. There was nothing mysterious about the detection geometry at all. So then the real question emerges. If the warning time was normal, if the detection process worked perfectly, then why did some independent researchers flag JH2 as potentially anomalous in origin? That question leads directly into the part of the story the mainstream narrative refuses to touch. Because answering it requires discussing a possibility that sounds less like astronomy and more like science fiction. The possibility that some objects moving through Earth's orbital neighborhood may not be random debris at all. According to the 3IATLAS hypothesis, JH2 may only be the visible part of something much larger moving silently through the darkness beyond human perception. If you think this story ends with one harmless asteroid flyby, wait until you hear what researchers say is hiding inside the region of space our telescopes literally cannot see. And once you understand that blind spot, you may never look at the daytime sky the same way again. What if the greatest danger facing humanity is not the asteroid we can see, but the ones hidden forever inside the part of the sky we physically cannot observe? Because according to astronomers, there truly exists a region of space where Earth is effectively blind. Not politically blind, not technologically behind, completely blind by the laws of physics themselves. And if the 3IATLAS theory holds even a fraction of truth, that blind region may already contain objects moving toward Earth right now. This is where the story surrounding JH2 changes from an ordinary asteroid flyby into something much more disturbing. The media focused entirely on the visible object crossing safely through Earth's orbital neighborhood. But behind the headlines, researchers studying long-term orbital clustering patterns have become increasingly interested in a far more dangerous category of celestial objects. These are not the asteroids approaching from deep space where telescopes can monitor them for years. These are objects traveling from inside Earth's own orbital geometry, emerging from the direction of the Sun itself. And that changes the entire equation. Ground-based telescopes rely on darkness. Every asteroid detection humans celebrate depends on reflected sunlight against a dark nighttime sky. But anything approaching from within the sun's glare disappears into brightness millions of times stronger than the surrounding atmosphere. Astronomers call this the solar elongation blind zone, a massive crescent-shaped region extending around the sun where optical observation becomes nearly impossible. No observatory can fully penetrate it. No military budget can solve it. No telescope on Earth can overcome the physics of photon saturation. That is the reality few people understand when they hear stories about asteroid detection systems. Humanity has never possessed complete awareness of what moves through near-Earth space. Half the battlefield has always remained hidden, and history has already shown what happens when something emerges from that darkness. A previously undetected asteroid once entered Earth's atmosphere above Chelyabinsk, Russia. There was no warning, no emergency broadcast, no evacuation order. The object exploded with an enormous energy release, producing a shock wave powerful enough to shatter windows across multiple cities. Hundreds were injured, mostly from flying glass and collapsing structures. Scientists documented the aftermath only after the detonation had already happened. Why was it missed? Because it approached directly from the sunward side. The asteroid traveled directly through the blind zone. Then, another object exploded over Akron, Ohio. Once again, there was zero warning. A multi-ton metallic rock detonated in the atmosphere before detection systems could identify its approach. Fortunately, the explosion occurred at higher altitude over sparsely populated terrain, limiting damage and casualties. But the implications were deeply unsettling. Even space agencies admitted the problem directly in official language, stating that humanity is completely blind to this region of the sky. That admission carries enormous consequences because it means the vulnerability is permanent until new space-based systems become operational. According to population estimates based on infrared surveys and modeling, thousands of potentially hazardous objects may still exist inside this hidden orbital region completely undetected. Current estimates suggest nearly 2,000 Aten-class asteroids larger than 150 meters may orbit within the sunward blind zone. Humanity has cataloged only a tiny fraction of them. For every confirmed object we know about, Dozens more likely remain invisible beyond observational reach. Now, combine that reality with the speculative 3IATLAS hypothesis. According to researchers studying anomalous clustering patterns, some of these objects may not simply wander randomly through space. Certain trajectories appear unusually organized. Certain orbital intersections occur with statistical regularity that some theorists argue cannot be explained entirely through natural gravitational perturbations. The implication is deeply controversial. What if some near-Earth objects are not random remnants of planetary formation at all? What if certain projectiles have been accelerated, redirected, or systematically delivered into Earth-crossing paths over extremely long periods of time? No mainstream institution officially supports this conclusion. But the theory persists because the clustering anomalies continue appearing inside independent orbital analysis databases, and every unexpected atmospheric detonation adds new fuel to the debate. JH2 itself may not be dangerous. In fact, this flyby represents the system functioning exactly as intended. Astronomers detected the object, tracked its orbit, refined its path, and confirmed no collision risk. That is how asteroid defense is supposed to work. But the visible asteroids are not the frightening part anymore. The frightening part is the category humanity cannot monitor consistently, the invisible companion class. Objects moving inside Earth's orbital boundary, objects approaching from daylight, objects hidden until the final moments before atmospheric entry. According to the 3IATLAS framework, these hidden projectiles may share origin signatures suggesting something far stranger than ordinary cosmic debris. Scientists are trying to close this dangerous observational gap. Upcoming space missions will use infrared detection systems positioned in space to search regions too close to the Sun for ground telescopes to observe. Future European systems aim to expand that capability even further. Together, these platforms could dramatically reduce the blind zone for the first time in human history. But until then, the vulnerability remains. A significant time gap still exists before the operational deployment of these advanced platforms. Even after launch, complete coverage will take years. During that period, countless unseen objects may continue traveling through solar glare completely unnoticed. Probability does not care about human timelines. Statistically, large atmospheric detonations occur every several decades to every century, depending on object size and composition. But probability is not a strict schedule. The next event could happen tomorrow morning or decades from now. No one truly knows. Which brings us back to the uncomfortable truth hidden underneath asteroid headlines. JH2 is the object humanity can see. The real concern may be the one we cannot. And if the 3IATLAS theory is correct, then somewhere right now, beyond the solar elongation boundary, another object may already be moving silently toward a future encounter with Earth, while civilization remains completely unaware of its existence. For decades, humanity has comforted itself with a simple belief about space. The universe is chaotic, violent, and random. Asteroids collide, planets form, debris drifts endlessly through gravitational currents without purpose or direction. But what if that assumption is wrong? What if at least some of the objects entering Earth's orbital neighborhood are not random at all? Because hidden deep inside the controversial 3IATLAS framework lies a theory so unsettling that most mainstream scientists refuse to discuss it publicly. The theory suggests that certain asteroid trajectories may carry signs of intentional acceleration, not natural scattering, not accidental orbital drift, directed movement. According to independent analysts studying anomalous asteroid clustering patterns over the past 2 decades, JH2 may represent one visible example of a much larger system operating beyond humanity's observational limits. The first clues reportedly emerged during comparative orbital analysis involving Apollo-class and Aten-class asteroids. Under normal conditions, asteroid trajectories distribute themselves through predictable statistical patterns shaped by gravitational interactions with planets, solar radiation pressure, and collision history stretching back billions of years. Most objects follow those expectations closely, but some do not. Researchers working within the speculative 3IATLAS model claim certain near-Earth objects appear to share strange trajectory similarities, despite originating from regions where such alignment should be mathematically unlikely. Some arrive along remarkably consistent approach corridors. Others display unusual velocity relationships, suggesting synchronized perturbations rather than isolated random movement. At first, these anomalies were dismissed as coincidence. Space contains enormous numbers of objects, and statistical clustering happens naturally. But over time, theorists began noticing repeated patterns associated with objects emerging from Earth's sunward blind zone, the very region humanity struggles most to observe. That correlation changed the conversation completely, because if hidden objects repeatedly emerge from similar orbital pathways, one possibility becomes difficult to ignore. Something may be influencing their trajectories before they enter detectable space. No official scientific institution has endorsed this conclusion. There is no confirmed evidence of extraterrestrial engineering or artificial propulsion systems. The overwhelming majority of astronomers continue to interpret these anomalies within conventional frameworks involving resonant gravitational interactions and incomplete observational data. But the 3IATLAS hypothesis argues that explanation may no longer fully account for what researchers are seeing. And that brings us back to JH2. Officially, the asteroid's trajectory appears harmless and stable. Yet speculative telemetry analysis allegedly identified characteristics inconsistent with typical formation history. Some analysts claim its reflection profile suggested unusual surface composition. Others focused on acceleration behavior during orbital refinement. A few even questioned whether its path resembled an ejection vector more than a naturally evolved orbit. That word ejection sits at the center of the entire controversy. Because if an object was ejected, then something ejected it. Most asteroids originate from ancient collisions inside the main asteroid belt between Mars and Jupiter. Over immense periods of time, gravitational interactions slowly alter their orbits until some drift toward the inner solar system. That process is well understood. But theorists studying JH2 argue its movement resembles a different category entirely. Instead of gradual drift, the object appears consistent with rapid displacement from a distant source beyond conventional detection thresholds. Imagine a projectile launched across cosmic distances, not recently, possibly centuries ago, possibly longer. The terrifying aspect of this theory is not the idea of one dangerous asteroid. Humanity has always lived with asteroid risk. The terrifying aspect is the possibility of systematic targeting across enormous spans of time. According to the speculative framework, Earth may not simply exist in a hazardous cosmic environment. It may occupy a trajectory corridor intersecting repeated delivery paths. Over centuries, those paths could generate periodic encounters disguised as natural impacts. Again, there is no proof of intentional hostility, but some researchers argue the clustering patterns appear too structured to dismiss casually. History adds fuel to the concern. When scientists reconstructed trajectories for past atmospheric detonations like Chelyabinsk and Akron, they discovered many shared similar sunward approach geometries. Even older impact records show intriguing directional overlaps when analyzed under alternative orbital models. Individually, these details prove nothing. Together, theorists claim they hint at something humanity has failed to recognize: a pattern, a mechanism, a system hidden inside what civilization currently labels random cosmic behavior. The mainstream scientific community strongly resists such interpretations for understandable reasons. Extraordinary claims require extraordinary evidence. Right now, the 3IATLAS hypothesis remains speculative by every formal standard. But the theory persists because it attempts to explain one uncomfortable reality conventional astronomy still struggles with. Humanity's observational blindness creates enormous gaps in our understanding of near-Earth space. We only study what we can see. Everything else remains inference. Until advanced infrared platforms become operational, enormous regions around the Sun will remain effectively hidden from continuous monitoring. That uncertainty allows theories like 3IATLAS to survive. Some analysts involved in speculative modeling believe the clustering patterns do not merely suggest random repeated encounters. They believe timing itself may matter. According to the framework, certain orbital intersections appear to unfold in long duration cycles spanning decades or even centuries. The implication is staggering. If correct, some objects currently traveling unseen through sunward space may already possess future encounter dates mathematically locked into Earth's orbital path. Not next week, not necessarily next year, but someday. Humanity would remain completely unaware until those objects finally emerge from the blind zone. That possibility transforms a harmless flyby into something symbolic. JH2 is not frightening because it threatens Earth today. It is frightening because it exposes how little humanity truly knows about the hidden half of near-Earth space. The visible asteroid becomes a stark reminder of the invisible system operating behind it. And perhaps most disturbing of all, the public conversation never reaches this level. News coverage reduces asteroid events into short, dramatic headlines designed for clicks and television segments. Close call, stealth, asteroid, near miss. But almost nobody discusses the deeper issue. Humanity still lacks continuous visibility across large portions of its own orbital environment. According to the 3IATLAS theory, that darkness may already contain objects moving with purpose. Somewhere right now, beyond the daytime sky, something could already be traveling toward a future encounter while Earth remains entirely unaware. It has a trajectory, a velocity, a date. But until it crosses the threshold of visibility, humanity will know absolutely nothing about it. The most dangerous part of humanity's asteroid problem is not the impacts we predict, it is the impacts we never see coming. Once you understand the mathematics behind our detection systems, you begin to realize something deeply unsettling. Civilization is not standing guard over Earth with complete awareness. It is scanning fragments of the sky through narrow windows of visibility while enormous regions remain hidden behind the blinding light of the sun. A flyby like JH2 may look like proof that the system works. In reality, it exposes how incomplete that system still is. Because the truth is brutally simple. Humanity detects asteroids by reflected sunlight. That single fact controls everything. Ground-based telescopes do not magically see objects in darkness. They detect tiny amounts of sunlight bouncing off rock surfaces millions of kilometers away. The smaller the object, the less light it reflects. Because reflected brightness decreases rapidly with distance, detection capability collapses quickly. A small asteroid like JH2 becomes visible only when it approaches relatively close to Earth. That is why warning windows are often short. Not because scientists failed, not because observatories malfunctioned, but because physics imposed a limit. And yet mainstream coverage transforms normal detection timelines into dramatic stories about stealth asteroids sneaking through weakened defenses. Headlines imply humanity narrowly escaped catastrophe. But researchers studying orbital detection systems argue the real catastrophe would involve an object approaching from the one direction Earth still struggles to monitor directly from the sunward blind zone. That is the ultimate nightmare scenario. Imagine an asteroid larger than any recent impactor approaching Earth from inside our orbital path. Ground telescopes would see nothing. The object would remain hidden inside daylight brightness until the final hours before atmospheric entry. Depending on its size, civilization might receive no warning at all. This is not speculation. It has already happened on smaller scales in recent history. Major detonations approached from geometries overwhelmed by solar glare, bypassing existing warning systems entirely. If you want to stay ahead of the secrets hiding in